Alright, welcome everyone again to another episode of physics series. We'll look at questions, real life questions, and how we can solve them with the knowledge of mathematics. Okay, so let's look at the question we have for today. A palm fruit dropped to the ground from the top of a tree 45 meters tall. How long does it take the palm fruit to reach the ground? Please like this video and share it, okay, to other students that are struggling with physics to be of very help to them. Okay, so let's proceed. Now, I like diagrams when solving questions involving physics. So let's proceed with this one so that you can get a clear picture of what the question is saying. A palm fruit dropped to the ground from the top of a tree. So let's assume that this is our ground floor. Okay? And this is our tree. Alright? And this is our diagram. So, okay, so we have fruits on this tree. So like a particular this one right here, dropped to the ground. Okay, so dropped to the ground. Oh yeah, dropped and then landed right here on the ground. Okay, so now before this fruit can drop to the ground, there's something it must possess. In physics, we call it initial velocity. It is the velocity a body possesses when it's about to move or before it moves. Okay, initial velocity. Now, since this fruit was on this tree all along, that means the initial velocity we will symbolize as u in physics is going to be 0. What does that mean? It means that the fruit is at rest. So we say the fruit is at rest. So when the body is at rest, according to Newton's first law of motion, that the body will continue to remain in a state of rest until an external force acts upon it. So maybe the external force that acted upon the fruit, now maybe wind or maybe any external agent. Okay, so maybe wind acted on it, then it was no longer in at rest position, and it landed on the floor. So but initially while it was on the tree, the fruit was at rest. Okay, so now the initial velocity of the fruit is 0. So that is what happens to any body at rest. The initial velocity is 0. Now, we were told that we asked to find how long does it take. So how long means time. So time. We don't know the time. So we have to find how long does it take. What's the time, the duration for the fruit to go from this point to this point? So we don't know. So, but we're given something called g, and g is called the acceleration with respect to gravity, or the acceleration due to gravity. G always acts when the body is either going upward or falling downward. Okay, but when the body is going horizontally on a straight line, G does not act on the body. It has no right to act on the body because the body is not looking for a struggle. Okay, so if you want to find the drop of G, I want to offset G, act upward or act downward. Alright, so we have G to be 10 meters per second square. It's a constant actually, it's a constant value, so it's getting towards 10 meters per second square. Now, how long? Now they give us something else. The tree is 45 meters tall, so the height of the tree is 45 meters. So that is the height or distance, vertical distance, 45 meters. Now, this is a case study of an equation of motion with respect to gravity. Okay, so we have our initial velocity, we have the velocity for the time, we have our acceleration due to gravity given to us in the question, and then we have the height of the tree or the vertical distance through which the fruit fell. Okay, so 45 meters. Now, if you recall, we have 4 equations of motion. 4 equations of linear motion. When it comes to gravity, we only have 3 because only 3 of the equations are considered gravity. Now, the first is phi equals to u plus or minus gt. The second is v squared u squared plus or minus 2gh, or you can say 2gs. And the third is s or h equal to ut plus or minus half gt squared. Now, if you check these three equations for gravity, you see that there's something to take note of, and that is the fact that there's plus or minus, plus or minus. What does that mean? It means that gravity can either act in the positive direction or in the negative direction. Now, in this case, since the fruit is falling by itself, it's being assisted by gravity to fall, it means that gravity will be positive, it's assisted, they are friends, they are not enemies. But in the case where if I throw something up, for instance, this matter with me, I throw it up, you want to fight against gravity because anything that goes up according to science must surely come down. Alright, so the fruit is falling, so it's being assisted by gravity to fall because the aim of gravity is to make it to fall. Anything that goes up comes down. So that means we're going to use the positive side of this equation. Now, how do we know which of the equations to be? We have three of them. How do we know? All we need to do is to check out the parameters we listed that are associated with the fruits and check which of the equations contain the four parameters. We have u, we have t, we have g, and we have h. If you look at the first one, there is v here, so automatically that disqualifies us from using the first one. Look at the second one, there's another v, that disqualifies us, irrespective of the fact that we have g and t and u. But because there is v, disqualified. V also disqualified. But look at the third one, there is h present, there is u present, there is t present. What we are looking for, there is g present and there is t present. So we go with equation 3. So as long as the equation contains four of the parameters it's okay for you to use that equation. Now, you only be given three parameters, sometimes two. Most of the times you will not be given initial velocity, but you know that when the body is at rest, the initial velocity is 0. If the body is not at rest, if it is moving, you will be given the initial velocity in the question. So let's proceed with equation 3, which is h is equals to ut. Don't forget plus rgt squared. Plus because the fruit is dropping positive. If I'm throwing the fruit upward, it will be negative. So let's go on. So h is 45. Our u is what? 0 times t plus r. Our g is 10. Our t is t squared. Oh no, we're looking for the unknown. So we have 45. This is 0 plus 2 can divide here, which is 5. That's possible because we have times here. So half times 10 times t squared. So 2 can divide is 5. So we have 5t squared. So we have 45 equals to 0 plus 5t squared is 5t squared. So divide both sides by 5, rather, by 5. Then 5 here, 1, 5 and 45, we have 9. So that t squared is equals to 9. So if we take the square root of both sides, t becomes 3 seconds. I know some persons want to say you have plus or minus 3 because this is square root. But we're looking at the positive aspect of the time because time cannot be negative. You cannot have minus 35 seconds. I walk from this place to that place in minus 35 seconds. No, that's how I'm not considering the negative part of this. In maths, you can consider it. But this is an applicational question, a real life question. So we're looking at the positive value for t, which is 3 seconds. That means the time it took the fruit to drop from the tree is what? 3 seconds. Thank you very much. So like and share this video to other students that are struggling with physics. We'll see you in the next series.